Here's our next section of two-sample hypothesis testing. We're still using independent samples, so two different groups that we are comparing, but now our population standard deviations are unknown. So for this, because we don't have population standard deviations, we're thinking t-tests. We're still going to need to find that it says random. Again, it might explicitly say independent, or you might have to determine from the scenario that they are independent samples. And we are looking to see normally distributed, or both groups need to be greater than or equal to 30. Now, with this section, though, there's going to be one more piece of information that they're going to tell you, and that is whether they are equal or unequal variances. That nugget of information is going to change the formula and change how you find degrees of freedom. So we've got to watch for that. So if it states in the problem that the variances are equal, it's a pooled estimate of our standard deviation, this is the formula we use. So this is for equal variances. And if that's the case, then to find degrees of freedom, we are going to add our two sample sizes together, minus 2. On the other hand, if it says variances are not equal, meaning they're not pooled, this is the formula we use, which is much more similar to our last section with our Z distribution with two sample. And then for degrees of freedom, it is whichever sample size is smaller minus 1. So you're going to compare the two sample sizes, whichever one is smaller, take minus 1 from that. That will be your degrees of freedom. So same order of steps. Again, when you are checking the conditions, the big thing with this one is you're going to look for whether it is that equal or unequal variances. That's going to be a big clue to let you know that we are going to be using a t distribution, but it's also going to tell you which formula and which degrees of freedom. We're going to state our hypothesis. We're going to be given our level of significance. We're going to find that critical value with inverse t, sketch out our rejection regions, make sure you're using the correct formula, check to see if it's in our rejection region, and write our conclusion sentence. So we've got two examples in here so you can see one of each of our two formulas. So this first example states, the results of a state's mathematics test for random samples of students taught by two different teachers at the same school are shown below. Can you conclude that there is a difference in the mean mathematics test scores for the students of the two teachers? Use the level significance of 0.10, assume the populations are normally distributed, and the population variances are not equal. So first thing that jumps out at me is the last bit of that population variances are not equal. So this is those unequal variances. This is the smaller of the two formulas, the one that looks more similar to a Z distribution. So this is the one on bottom with the S1 squared over N1 plus S2 squared over N2. That's the bottom of the formula. And then for this one, degrees of freedom, it's whichever one is smaller of our sample size than minus 1. So let that be in your mind which formula we're using. And that's going to be part of our conditions, is that we have unequal variances. Other things that we're looking for is that we're given a sample standard deviation. So we don't have population standard deviation. It does say random samples. It does say normally distributed. It doesn't clearly state the word independent, but it does say that they are two different teachers. So that is letting you know that this is independent. So all of those pieces together is what's giving us a t distribution. So those are all of our conditions to let us know what kind of test we are doing. Keep in mind, a lot of the two sample data sets are going to give you a nice little chart. Sometimes it's in a chart, sometimes it's in the wording of the paragraph, but everything should be there. So two sample means, two sample sizes, two standard deviations. The only other thing we need to note before we go to the next slide is that we do have our level of significance. And then also we need to look for our term. what inequality term they give us to set between our two means. So it does say, can you conclude that there is a difference in the mean mathematic test scores for the students of the two teachers? Difference is implying you're not equals. So that's the symbol that is our claim. So let's write that out. HOHA, we are comparing two different means. And it does ask for a difference, so that's our not equals. That goes in HA. The complement would be our equal sign. And our level significance is 0.10. Now we can make our sketch. HA is telling us that we have a two-tail because of the not equal symbol. So inverse T, we're going to plug in half of alpha because it's two-tailed. And then our degrees of freedom is the smaller of our two sample sizes. So we had an 8 and an 18. 8 was smaller. So this is coming from 8 minus 1. So inverse T, we have our area and our degrees of freedom. We have two tails, so we want plus or minus, and we're going to round it off to 4 decimals. So 1.8946. Again, positive and negative on our sketch. Shaded areas mean to reject. We get somewhere in the middle, it is fail to reject. Now let's jot down our formula. Difference of our sample means minus difference of our population means. Our standard deviation squared over our sample size. For each group added together underneath the radical. So we can start to plug in everything they gave us. Keep in mind we're plugging in 0 for the population mean in the back because we don't have any known difference between the two groups. So we are assuming they are equal from the get-go. And if they are equal and they are the same number minus itself would give us 0. That's where we get that 0 from. So type all of this in at once. Don't forget the squares on your standard deviations. Round it to 4 decimal places. And then check that number to your sketch. So 0.9 is somewhere in the middle, just a little to the right. It is not in our shaded area, so we call this fail to reject for our decision. So then we could write our conclusion sentence. At a 10% level of significance, that's always coming from your level of significance from the beginning. So it doesn't matter if it's 1 or 2 tails, you use the whole thing. There is not, it's coming from our decision, fail to reject, enough evidence to support the claim. Support is coming from the fact that our claim is our HA. If our claim was HO, we would have used the word reject. The claim that, and I like to put the dots there. Let's hop back to the wording of our problem, because you would copy and paste it from that there is a difference in the mean mathematic test scores for the students of the two teachers, all the way down to that question mark that we would just switch to a period. That's the sentence that's giving you that these are means, the scenario, we're comparing test scores for two teachers, and our inequality term difference. So it's always that little segment from the wording of the problem that includes the inequality symbol. That's the sentence we want. Now let's try another example. This one says a manufacturer claims that the mean driving cost per mile of its sedans is less than that of its leading competitor. You conduct a study using 30 randomly selected sedans from the manufacturer and 32 from the leading competitor. The results are shown. A level significance of 0.05, can you support the manufacturer's claim? Assume the population variances are equal. So that last little line there, population variances are equal, that's letting you know that this is going to be a t distribution. That's your big clue. So equal variances. Also note that you were given sample standard deviation. So you don't have any population standard deviation. It does say random. Making a random selection here. These are independent. You have a manufacturer and competitor, two different groups. And our sample sizes are at least 30 or bigger. So for both groups, n is greater than or equal to 30. All of that together is letting you know to use a t-distribution. And the big one is that equal variance is letting you know which formula and degrees of freedom we need. So we have all of our information from our chart, plus we have our level of significance. The last thing we need is our inequality term. So it's going to come from the sentence where it states who is making the claim and what claim they are making. So in this case, it's our first sentence. The manufacturer claims that it is less than. So the manufacturer is less than the leading competitor. That's our symbol, less than, that's going to go in HA. So HO, HA for our hypothesis, mean 1 and mean 2. Less than goes in HA, so that's our claim. It's matching the wording of our problem. Complement symbol for HO. Level of significance is 0.05. Then we can make our sketch. HA is always the one that's telling you whether it's left tail, right tail, or both. So less than for HA means left tail. So inverse T, we're going to drop in all of alpha because it's one tail. And for degrees of freedom, because it's equal variances, you are going to add your sample sizes minus 2. So that is for us 30 plus 32 minus 2. We get 60. 60 for degrees of freedom. We want negative for our critical value because it is less left tail. So 1.6706, and we do want it negative. Put it on our sketch. Shaded area is our reject. Not shaded is our fail to reject area. Now, equal variances is the slightly bigger formula. So underneath that first radical, you're going to take each sample size minus 1 times the standard deviation squared for each group, add it together, divide it by the degrees of freedom. That's under one radical. Stop the radical and type in your times, and then it's 1 over each sample size added together. So that is all on the bottom of this fraction. So there is a calculator video that will show you how to type that in your calculator just to make sure you get everything where it should be. Then we plug in all of the pieces, the sample means, the sample standard deviations, our sample sizes. I'm squeezing it to fit on here. Again, this is all in the bottom of that fraction. You want to type this all in at once. I know it seems like a lot, but do it all at once. So when you click enter, you get the whole answer at once. You don't want to be rounding individual pieces off as you go. So negative 1.9303. It is in our shaded area if we look at that number line on that normal curve. So our decision is to reject. So our last step is our conclusion sentence. At 5% level of significance, because we rejected, we say there is enough evidence to support the claim. Support is coming from the fact that our claim was HA. So support the claim that, and I'm going to put the ... Hop back to the wording of our problem. Look for, again, where that sentence is that has our inequality statement. So claims that the mean driving cost per mile of its sedans is less than that of its leading competitor. You would copy and paste the rest of that into your sentence.